Hi, Dr. Atchison here. We're still talking about Chapter 1. This is our second lecture for Chapter 1. We're going to be talking about psychological research methods. So as we already talked about, psychology is a science. And so we employ this scientific method in our research questions. There's different ways we can answer our questions, and some of that depends on the kind of question we have. Sometimes we'll answer our questions using descriptions of behavior, descriptions of processes. Sometimes we'll answer our questions using relationships or correlations. How are two things related? And sometimes we'll look at cause and effect, and that will be that we can only do that with experimentation. And we'll talk about each one of those in more detail. So the scientific method, I know we've been learning about this since elementary school. I know my daughter learns about the scientific method currently, but it never hurts to have a refresher. There are 5 steps to the scientific method. The first is we need to identify the problem and form a hypothesis. Now remember, our hypothesis is our prediction about what we think is going to happen. It's not the research question itself. That's the problem, right? The hypothesis is what we think the answer to that question is going to be. It's our prediction. And we come up with that prediction based on what we already know. And scientists use the previous literature. So when we talk about research and we talk about this ongoing conversation that the scientific community is having, that's primarily happening through research papers. So we will form our hypothesis based on the research that we have already been done. The next step is going to be design the research study, and the kind of question you have puts parameters on the kind of research study that you can do. And there'll be ethical issues that we can talk about in the next section as well. Then comes the fun part, the actual conducting the research study, doing the research itself. And this is the part that usually takes the longest. Sometimes designing the research can be very long, but depending on your sample size, conducting your research study can be a very, very long process. We're going to test that hypothesis. This is when we're going to look at the results, okay? So we're going to take the data, the results that we got from that research study, and we're going to test it. This will be done using statistical methods, which you guys really aren't responsible for in this class. We'll talk about it a little bit when we talk about correlation, because that is a statistical method. But that's what we're doing to test the hypothesis. We're comparing it against what we know about chance. And then finally, communicating the research results. Now remember when I said that first step, we're forming our hypothesis based on other research results. You can see how this is very circular process then, right? So you form a hypothesis based on other research results. And then at the end, you communicate those results so that other hypotheses can be built upon this research. So it's a very cyclical process. Again, it's kind of a commutative process where it's an ongoing conversation between researchers throughout their own field and other fields as well, and with the public as well. So in designing the study, again, that depends on the research question that you have. One way that you can design a study is a descriptive study. And in a descriptive study, our main objective is to observe and describe typically behavior in psychology. And there's different ways that we can do this, and we'll talk about all 3 of them. We have naturalistic observation, case studies, and surveys. Another way that we can design a study is through these relationship or correlations. And we'll look at a relationship between 2 or more variables and see if they vary together. Okay, and we'll talk about this in more detail. And finally, our gold standard in research, the experiment. And the reason this is the gold standard is because experiments are the only way we can look at cause and effect relationships. So in correlational methods, we'll be able to see if there is a relationship, but we will not be able to tell if one thing is causing the other. The only way we can do that is through experimental methods. And we'll talk again about all 3 of these in more detail. So again, let's talk about some research basics. A theory is this integrated set of statements that in psychology are going to explain and predict behavior. So it's a tentative explanation for observed findings. And this is really, sounds a little like kind of a hypothesis to begin with, but it's much broader than a hypothesis. It's in fact based on findings from a whole bunch of different studies. So I like to kind of think of it as like an umbrella. And an umbrella that has all these different research studies in it. And it's the common idea the common explanation that we have about what's going on based on all these other research studies. And this will change. The theory is going to change based on what the research shows and what the research says. A hypothesis comes out of a theory, okay? So again, remember we said our hypothesis is based on previous research, is based on previous knowledge, which has formed that theory. So our hypothesis, again, kind of comes out of this theory. And it's that prediction about what we think the answer to our research question is going to be. So it's our prediction that proposes a relationship between two variables, or a prediction about the description of variables. It's our prediction. It's our best guess based on this information we have about the answer to our research question. When we're doing research, we also need to talk about things like operational definitions. Now, an operational definition is a precise description of how the variables will be measured. So if you're doing a study on exercise, there's thousands of different ways you can exercise. So an operational definition would precisely say, when you say someone's going to exercise an hour a day, what do you mean by exercise? Do you mean that they have to walk for at least an hour a day? Do you mean that they have to get their heart rate up to a certain for an hour a day? Is it a specific kind of exercise? Does it only count if it's on a treadmill or an elliptical or something like that? Or can it be gardening? Because that can be exercise. So an operational definition is going to be the precise description of how that variable is going to be measured. A really important part in this research is replication. So replication is when you do a study, you find the results, and great, we found the results. That sounds like something is happening here. We say we think our hypothesis was right, but you notice I say we think our hypothesis is right. Not that our hypothesis is definitely right. One study doesn't prove anything. And in research, and especially in psychology, we don't like to use the word prove because one study doesn't really prove anything. It might suggest something. Now, what you need is you need replication. You need to be able to find those same results over and over and over again. You're replicating, think about like a copy machine, right? You're replicating the results of a previous study. And when you can do that, and you can find the same thing over and over and over and over again, you can come to a scientific consensus. And then we can say, hey, I think this is what's going on. In the case of things like evolution, there's been a scientific consensus that they think this is what's going on. In the case of climate change, there's a scientific consensus that says this is what's going on. They have replication of their findings over and over and over and over and over again. We'll talk a little bit about autism and vaccines. There was not replication of the study that said that vaccines caused autism. In fact, they found that he actually falsified his data. There is no replication. And in fact, there's been so many studies that have done to try and find that link, and it's not there. There's a scientific consensus that vaccines do not cause autism because there was not replication of that one study, and there's a scientific consensus about the lack of relationship between those two variables. Okay, so now that we kind of have a basic lingo down, let's talk about those different research methods again. So descriptive research methods, one of which is naturalistic observation. This just describes behavior. It doesn't explain it in any way. So an example of maybe a naturalistic observation study is if you're trying to measure, say, let's call it, say, altruism. And you just sit outside Langdale and you look at behaviors that are altruistic, holding the door for someone else, letting someone else go in front. You'll operationally define these things, but nobody knows you're watching them. This really minimizes observer effects. When you know you're being watched, you behave differently. And so naturalistic observation is just somebody sitting somewhere recording behavior without the other people really knowing. And this really actually can enhance reliability. And that's what this says. This protocol really enhances reliability. It's kind of hard to see that reliability under that picture, but that's what this says. So again, this is somebody sitting somewhere watching behavior, unbeknownst to who they're watching. So it's very, very naturalistic. We see this a lot in animal studies. They'll try and hide from the animals so they can see really natural behaviors. We'll see it in a lot of other kinds of studies as well. Developmental studies, sometimes they'll do that, things like that. So that the idea is that the behavior is really true to form. It's what it looks like in a natural setting. Another example of descriptive research methods are case studies. And case studies is a highly detailed description of one person. So there's somebody that's interesting in some way, and it is a very detailed research study involving one person. This does not uncover general truths because we're talking about one person. And what's true for me is not true for you, right? You have to have, to be a general truth, it needs to be kind of true for everyone. And so these case studies will be very interesting and we'll get information out of them, but they're not going to uncover general truths. These are generally used to investigate really rare, unusual, or extreme conditions. So this is a little picture of a little girl named Jeannie, and she was extremely neglected by her parents to the point that she was locked in a room until she was 7, I believe, and she wasn't spoken to. She was fed, but that was about it. She had very, very little human interaction, and so this severe neglect by her parents gave her a huge amount of developmental delays, and it taught us a lot about critical periods of development and how we have to have certain information in to that child for them to develop properly. And so this is a very rare, thank God, situation where this child was so severely neglected. And her caregivers afterwards collected lots and lots of data and information on her behaviors and on her processes and on her mental functioning and on her language skills to really see the effect of this neglect. Another way we can do descriptive research methods is surveys. These can investigate opinions, behaviors, characteristics of a particular group. So when you hear about a poll or a political poll, that is a survey. That is descriptive research methods. They're trying to get opinions about a particular group of people. These are usually in self-report form. So you're saying, this is how I feel about this, or this is what I do about this, or this is how I behave here, or this is a characteristic I have. And so that is not, again, going to tell us anything more than to describe these opinions, describe these behaviors, describe these characteristics. Because it's self-report, we're not always 100% accurate in what we report about ourselves. We want to make ourselves look better. And so there are issues with that. Another kind of research method is correlational research methods. And remember I said that this is looking at 2 or more variables and their relationship with each other. So example would be measuring a parent's disciplinary style and then measuring a child's behavior. To examine the relationship between those 2 things. Are they in relationship? Does disciplinary style affect children's behavior? Are those 2 things, are they working together? Or does children's behavior affect their parents' disciplinary style? Or is there something else entirely going on? But are these 2 things in relationship together? Do they go up together? Do they go down together? When one goes up, does the other go down? How do these things work in relationship with each other is what correlational research methods are looking at. So it examines this relationship between the variables. It looks at the direction of these. So again, do they go up together? Do they go down together? Do they go in opposite directions? And how strong this is. Do they all go up together? Do they all go down together? Or is it just some of them that are going up and down together? Is it not kind of something that's happening in every instance? So an example of a direction would be maybe if parents that had more democratic political leanings had children that behaved better. Both of those things go up together. The more democratic they were and the child's behavior, they're going up together. That's talking about direction in a correlation. Now, correlation, as I said before, does not prove causation. Correlation will not tell us cause and effect. And the media is really, really bad about this. They will take a correlational study and they will sensationalize it. Does ear hair cause heart attacks on 11 News at 10? They make these things sound like they're cause and effect, and they're not. Do heart attacks cause you to grow more ear hair? Again, we don't know. A correlation doesn't tell us if either one of these things are true. It may be a third unmeasured common factor. In this example, it could be age increases both the risk of heart attacks and the risk of ear hair. So it's not that ear hair is causing heart attacks or heart attacks are causing ear hair. It's that age is this unrelated factor that's causing both of them. So here's kind of a graph that talks about that. In the situation of correlation, you have three possibilities of causation. You can have that variable 1 is causing variable 2. So low self-esteem could be causing depression. But you could also have that depression is causing low self-esteem. Or you can have that this third variable, in this example, one third variable could be distressing events or a biological predisposition could cause both low self-esteem and depression. And you don't know. So we also know that crime rates and ice cream sales are highly correlated. Okay, so these have a really, really strong positive relationship. When crime rates go up, so does ice cream sales. When ice cream sales go up, so do crime rates. Now, I do not think that crime rates cause ice cream sales, right? I don't commit a crime and go, you know what I really need? I need some ice cream. Ice cream also does not make me want to commit a crime. Now, the third variable that we now know is involved in this correlation is heat. When it's hot outside, you're more likely to buy ice cream. When it's hot outside, you're more likely to commit a crime. I know when it's, 95% humidity outside, I'm not in a great mood. And crimes are a lot more plausible than they were when it was a normal day outside. So it's really important to remember that correlation does not mean causation. It does not mean that one causes the other. And again, the media is really, really bad at suggesting that correlation does cause causation. Now, I talked about both direction and strength of correlations. When they're a positive correlation, that means that both of them are increasing together. Both of those variables are increasing together. When it's a negative correlation, that means as one increases, the other one decreases. And the strength of that correlation, so we were talking about positive and negative correlations, that's talking about direction of the correlation. The strength of that correlation is how regularly they do these things. So in a perfect positive correlation, as one event increases, the second exactly increases. So we have a nice straight line, just like we have in a positive negative correlation. These things are always moving together. Now, in weaker correlations, we start to get our dots a lot more jumbled. So we're still kind of getting a line in that 0.5 positive correlation you see, or that negative 0.5 correlation. You can kind of see the direction that they're going in, but it doesn't look as strong. It's not that pretty line that we have in either the perfect positive or the perfect negative. And then if you look at the zero correlation graph, those dots are all over the map because those things are not related at all. Those two variables are not related. Our last research method that we're going to talk about is experimental methods. And an experimental research is the only way we can look at causal relationships. So that's cause and effect. It's the only way that we can say that one variable causes change in another variable. And the way that we do this is we systematically manipulate one of those variables. So that's our independent variable, and we're going to manipulate that in a way that we can observe any effect it has on the other variable. And that other variable is called the dependent variable. So if we were to do a study, and our research question was about breast milk versus formula and intelligence, okay? And in this example, we don't really have a hypothesis. In this example, we just have that research question that's given here. But to look at this research question, we need to break up our two groups. We need to look at a group of infants that only is exposed to breast milk and a group of infants that's only exposed to formula. Now, we need to do this in a random way. We can't already pick families that have picked formula versus families that have picked breast milk because they may have differences in those groups. So we need to take a group of families and say, hey, this half is only going to feed breast milk, and this half is only going to feed formula. Now, you can already see there's going to be design issues with that. That's not going to work out well. But if you did those two things, and you did get it to work out well, and then you took intelligence scores at age 8, you could start to look at if breast milk does have a positive effect on intelligence, which there is some research to suggest. So again, you're systematically manipulating one variable, in this case, the kind of milk the infant's getting, and you're measuring the effect that that manipulated variable, that independent variable, has on your dependent variable. Here, this would be intelligence at 8. And notice it says intelligence score at age 8. That's our operational definition. We didn't just say intelligence, because that could be anything. We're saying we're getting an IQ score, and we're measuring it at 8. That's our operational definition of intelligence that we're using. So again, an independent variable is the factor that researchers control or manipulate in order to determine the effect on behavior. Now, you need to have at least 2 levels of this. You can't just say, okay, well, I'm going to give everybody breast milk and see what happens. You have to compare it against something else. And this is why we need a minimum of 2 levels. We'll have an experimental condition, and then we'll have a control condition. So in the example before, you had your experimental condition as breast milk and your control condition as formula. Another example would be if we're looking at adjusting to college and how well-being and grades and those sorts of things afterwards. You could assign one group of students, randomly assign them to write about their adjusting to college, and another group of students to just write about superficial topics, and look at how those 2 variables might cause change in a dependent variable. So a dependent variable is the measure of behavior that is used to look at that effect. So this is what we're measuring. So the independent variable was manipulated or controlled. It's our manipulated variable. And our dependent variable is our measured variable. So in our example of looking at college adjustment, we can look at GPA. So maybe my hypothesis is if you better adjust to college, you're going to have a higher GPA. And I think that writing about that college adjustment will be beneficial for you versus writing about something superficial. Most studies often involve more than one dependent variable because a measure of GPA is pretty easy to get, right? You just look at a number. There's not a lot of effort involved. And so you can look at the effect that, say, this writing assignment would have on multiple dependent variables. So you could also look at some sort of characteristic of their health, how many times the student got sick, how this adjustment affects the student's overall well-being. Other maybe friendships, extracurricular activities, things like that you could look at as dependent variables as well. Now, we did an in-class experiment on the first day, and that was an experiment. Half of you were assigned to hear the paragraph with the title, and the other half of you were assigned to hear the paragraph without the title. Now, because the size of the class, doing truly random assignment was a little bit difficult, but my hypothesis was that whether you heard the title or not affected your memory retention. It caused a change in that measured variable, in that dependent variable. So my manipulated variable, what I measured, was whether you heard the title or not. My dependent variable, what we measured, remember, was your recall of the paragraph. And how we operationally defined that is we broke that paragraph into pieces, and we said, how many of these pieces did you remember? And again, this dependent variable is affected by the independent variable. So our hypothesis will say that our independent variable causes a change on the dependent variable. And so we say, knowing the title of the paragraph for our in-class experiment, my hypothesis will increase memory retention. My independent variable was whether or not the title was given. And notice that's in my hypothesis. My dependent variable was your memory retention for the paragraph. And notice that's in the hypothesis. So your hypothesis is talking about both your independent variable and your dependent variable in the case of an experimental research study. Now, let me give you some data. I don't have yours yet, but this is the data from the first time I did this, where the title students remembered on average about one more item than the no title students remembered. And this is about par for what the original study did. So remember we talked about being skeptical. So looking at this and say, okay, yeah, but you just did this in class. It wasn't really well controlled, so I don't know that really giving me the title or not giving me the title really affected my memory retention at all. So being skeptical is important, and going to the original source is important. So this was the first time this study was done by Bransford and Johnson in 1972. And this was essentially the same study that we had, except they had a third condition where they gave no topic at all. So you were either topic after or topic before. And we saw differences in that recall. So we see that in terms of recall, students that got the topic before remembered about 3 more items than students that got the topic after who got no topic. So this is a study that we both somewhat replicated in our class. And it's also a study that's been replicated again and again since it was originally done in 1972. So that ends our discussion about research methods for Chapter 1. Thanks. See you in class.